pressure looks good.
Doubling up. Roger, roll, Atlantis.
Water towers can fly! Yes!
Tango Delta nominal.
Flight down speed off. Bring in, speed off. Off.
Yikes. You bet. Concur. We don't need any more of these.
Welcome everybody. You are looking live at Launch Vehicle 0007 on the pad in Kodiak Island, Alaska. Astra is about an hour away from conducting a test flight with the goal of reaching orbit. We are coming to you live today from Astra's headquarters in Alameda, California. My name is Thomas Burkhart, News Director for NASASpaceflight, and I'm joined by Carolina Grossman, Director of Product Management at Astra. Carolina, thank you so much for joining us tonight.
Thank you, Thomas.
Astra and NASASpaceflight are partnering tonight to bring you this live broadcast. Thank you to Astra for covering some of the expenses associated with making that happen. As usual, we'll be taking your questions from chat over the course of the broadcast, so if you have a question about today's launch, tag at NASASpaceflight in chat, and we're going to answer as many of those questions as time allows. Let's start off with a quick status update on today's launch attempt. Carolina, how are we looking so far?
We are keeping our eye on some upper level winds, but we are proceeding with tonight's launch attempt, and you can see that the first stage has been filled with propellant, as indicated by that smoky white area for the top half of the upper stage.
And so if you are just joining us and maybe be new to Astra recently celebrated its 5-year anniversary. This is their 4th orbital launch attempt. So let's take a look at some clips from 2016 till now and Astra's 5-year anniversary.
The early days at Astra, we were all a real big family. We would all finish our morning meeting and then we would all gather downtown San Francisco, which is where we started.
30 or 40 people design and build and launch the first rocket.
Astra has been an exercise in becoming as efficient as possible, not only in the rocket that we're building, but also in the way the business operates.
What I'm most proud of so far was the Rocket 3.2 launch back in December, where we made it to space.
And watching the upper stage ignite and then take off.
I mean, everyone was elated, crying, screaming, jumping up and down.
Seeing the Earth flash up on the screen for the first time from the downward-facing camera on the upper stage, realizing that that was a picture being transmitted from the system that we just put into space.
Resilience that this team has shown and the grit that this team has shown over the past 5 years to get where we are today is just phenomenal.
The way that the team pulls together those times is amazing to watch.
My hope is that Astra maintains that culture of debate, but also respect.
What we were trying to achieve seemed unachievable at that time. And I think we all had to be very close and not just be coworkers, but be friends. We all embodied that, and it allowed us all to work hard and push each other to get to the point we are today.
We seem to take on these Herculean challenges and be able to knock them down at speeds and paces which are almost unfathomable, and it's amazing to see sometimes the way that we can get things done.
Quite a blast to see this company grow from like 6 people in a garage to where it is today. It's been quite a privilege to be able to see all that.
Happy 5th anniversary, Astra! Happy 5th anniversary, Astra!
Happy 5th anniversary, Astra!
A happy anniversary indeed to Astra. We're going to dive into some Q&A now to get a little more information about Astra and their mission. And we've got a set of questions actually coming to us from the Alameda Boys and Girls Club right down the street here from Astra. So let's take a look at that.
Hi, my name's Janai, and I am in 6th grade. And my question is, how long did it take you to build the rocket?
Thank you so much for that question, Janai. Right now, it takes us a few months to build the rocket, but we are getting faster and faster every time. One of the most interesting things, I think, is that a lot of the material that you see in front of you on the screen actually comes into our factory as sheets of metal and raw material, and we fabricate it in our in-house machine shop to become the rocket and the launcher that you see in front of you today.
Hi, my name is Maria, and I'm in 6th grade, and my question was, how high will the rocket go up into orbit?
Maria, that's a great question. For today's mission, the rocket will go 500 kilometers, or about 310 miles into orbit, and that's about the distance from Alameda to Los Angeles. The rocket will reach orbit in just about 10 minutes, though, which is a lot faster than traveling by car or plane from Alameda to LA.
Hi, my name is Amber. My question is, why is the rocket going into space?
Amber, thank you so much for your question. This is a test flight for us so that we can learn more about how to design and build rockets that can be launched in space on a regular basis. For this mission, we're partnering with the U.S. Space Force to test a payload and see what it would be like to launch real payloads in the future. And a payload is just the object that's being sent into space. For us, that will be different types of satellites that help our mission of improving life on Earth from space. So a lot of those satellites will be doing things like Earth observation to help monitor the warming of oceans and deforestation, or providing connectivity across the globe.
Hello, my name is Devad. I'm in 6th grade. And my question is, what is the benefit of making a smaller rocket?
Devad, we have a need for speed. By making Astra rockets smaller than other rockets, we're able to manufacture, transport, and launch on a faster timeline because we don't take up more space or materials than we need. In fact, our rockets fit in a standard shipping container, which makes it easy to transport them to the launch site. Also, a small rocket is easier to produce in a large quantity, which is important to us because our goal is to launch a rocket every day by the end of 2025.
Hi, my name is Nala, and my question is there a door on the rocket?
That's a good question, Nala. There are no people-sized doors on our rockets because we're not launching people into space, but we do have about a dozen access doors on the rocket that we use to complete inspections and repairs. They have really funny names like the Dork Knight, Finding Dory, Dorito, Gryffindor, Drewberry Door, Oakland Ray Doors, and Dora the Explorer. They can vary in size but are generally about a foot by a foot, and the payload is actually not installed through a door. The way that we install the payload is by taking apart that top pointy part of the rocket, which is the fairing, which comes in two halves, and then we install the payload and reinstall those two halves of the fairing.
Hi, my name is Glenn. I'm in 6th grade. And what are some benefits of launching a rocket in Alaska?
Glenn, that is a great question. We're launching from Alaska from the Pacific Spaceport Complex, Alaska, which is our launch station. And one of the good things about this launch site is that we can launch over the ocean, which helps keep the rocket away from people. And we work with the government to keep planes and ships away from the rocket's path. More generally, though, launch sites help determine which locations in space that the payloads on the rocket can reach. Many launches happen near the equator because that's where Earth's rotation is the fastest, and it gives rockets a boost of speed. Lots of satellites for Earth imaging and observation want to go to polar orbits, which go over the North and South Pole, so that they can observe all the points of Earth's surface. Launching from Kodiak, Alaska makes it easier to get to those kinds of orbits, and in the future we're planning to operate other spaceports in different parts of the world.
Hi, my name is Anna. I'm in 6th grade. My question is, how does a fire come out of the rocket?
Anna, that's a great question. The fire coming from our rockets is a large amount of heat and energy that's directed out of our 5 engines, which enable the rocket to lift off. They're fueled by an explosive combination of kerosene and liquid oxygen. And a fun fact is that a huge portion of the rocket is basically just a gas tank to fuel those engines for flight.
Thank you so much to the Alameda Boys and Girls Club here in California for all those great questions. We're going to get into some chat questions now. Again, if you have a question about the launch, tag us with @NASASpaceflight. We're bringing those in, and we've got a whole queue of them here. And we're going to start with the first question is talking about the previous launch for Astra, LV0006, which we saw earlier this year. Carolina, let's talk about what has been changed since then.
Yes, well, if you joined us in August, it was definitely a pretty unique rocket launch experience. Certainly nothing like anything I've ever seen before. And what happened is that the propellant system that loads the fuel and the liquid oxygen into the vehicle is designed to seal off and separate when the rocket lifts off at T0. Unfortunately, there was a small leak, and some of that fuel and oxidizer combined in the very, very hot exhaust from our engines, and combined with a lot of energy, and resulted in one of the electronic components of one of our engines sending a signal to shut off one of our 5 Delphin engines. And all of this happened in less than a second, so the team very quickly reviewed the data millisecond by millisecond, and we were able to uncover the cause of the issue, and within just a few weeks the team worked really, really hard and was able to separate the way that we load the propellants onto the vehicle to prevent this from happening in the future. And then more broadly, we looked at the way that we test and qualify and verify these components so that we can make sure that we never encounter those issues again. So hopefully that that solution that's in place tonight will prevent us from seeing that issue, and we will have much less sideways flight tonight.
Definitely hoping for a smoother launch tonight at just under 43 minutes and counting towards tonight's liftoff. Keeping the questions coming here, one from chat says, does Astra have any plans for other rockets after this one? So we're looking at a version of Rocket 3 right now, correct?
Yes, what we see is Rocket 3, and we have a lot of great plans for our future rockets, but in tonight's webcast, we're really going to focus on this mission with the U.S. Space Force. And if you want more information about Astra's plans and future, you can check out our website, and also our SEC filings are a great place to find information about our future plans.
We can keep talking about this particular mission because we should go into a little bit more detail about what the goals of today's flight actually are. It is a test flight. It's got a test payload on it. Can you just review what the other goals that we're looking to demonstrate here tonight are?
Yes, so we are going for an orbital launch attempt with LV0007. Our goals are to reach orbit, and the payload we have on this mission is a mass simulator, so we will not actually be deploying the payload that we have on this mission. And you can see we have a camera here that is pointing at lights that will signal when the simulated deployment signal would have gone off. Part of the reason why we do not want to deploy it is because it's an inert payload, and that would create space debris, so we are not deploying a payload tonight. This is the United States Space Force's second mission, STP-2782, and it is intended to demonstrate Astra's ability to deliver payloads for the Department of Defense.
We just saw that camera view inside the payload fairing, and we have a question in chat from Nathan asking, are you able to monitor the payload inside while fueling is underway?
Yes, so that camera is a good indication of how we visually monitor the payload, and we have all sorts of different sensors on board as well, where we are making sure that all of the environments on the upper stage where the payload is remains healthy.
What we're looking at on our screen right now is a live view of Rocket 3.3, the latest version of Astra's rocket, this particular one being LV0007 on the pad. And we see a lot of frost on the outside. We pointed that out earlier, and that's a sign of propellant loading. Can you explain why propellant loading shows us, why we have these visual effects for fueling underway? Is it a result of what propellants you're actually using?
Yeah, so the vehicle, both of our stages are fueled by the same propellants. We use our fuel is RPX, which is essentially kerosene, and we use liquid oxygen as our oxidizer. And the liquid oxygen that you see is that top white portion is very, very cold, whereas the kerosene is not as cold. So that's why you get that visual demarcation between the liquid oxygen and the fuel.
We're going to keep the questions coming because we've got a nice healthy queue. An update from the countdown net. The teams have just completed FTS checkouts on the pad, and the countdown is proceeding smoothly. We're under 40 minutes and counting now. Another question from chat asks, are there any other sites that Astra is planning to launch rockets from after Alaska's Kodiak site?
Well, yeah, as we mentioned from some of the Q&A from the Boys and Girls Club, we are Our future plans include many spaceports around the globe, but I just want to take this opportunity to talk about our partners at the Pacific Spaceport Complex, Alaska, and the Alaska Aerospace Corporation, who we've been very fortunate to work with over the last several years in launching our rockets, and we really, really appreciate their partnership and collaboration with our first test flights and hopefully for many years to come.
Kodiak is very interesting when we're talking about Astra, because Astra is one of the very few organizations that actually launches from Kodiak. Can you talk a little bit about some of the benefits and maybe some of the challenges from launching from there?
Yeah, definitely. So one of the benefits, as you mentioned, there are not many companies that are currently launching out of Kodiak today. This is a great zoomed out view, although it's a little dark. But what you would be seeing in the daylight is beautiful, beautiful scenery. Kodiak Island is just absolutely gorgeous, and because there are not too many launch companies that are launching out of Kodiak at the moment, we find that there is lots of availability for launch dates, and we really appreciate working with the community there. And I will say that the biggest challenge that we've experienced, especially with the preparations for this launch, has really been the weather. It is very, very cold, I believe around 15 degrees Fahrenheit out at the pad today, so a huge shout out to our red team for working in those cold conditions and making sure that our cold systems stay cold without freezing and our warm systems stay warm despite the cold ambient temperatures has certainly been a challenge that we face in launching out of Kodiak.
How does the rocket get to Kodiak? Because it's built here in Alameda, California, right?
Yes, so everything that you see actually fits inside a shipping container. So the rocket fits inside a 45-foot shipping container and is everything else that you see, all of the ground support equipment. We're able to ship using typical logistics over trucks and boats and sometimes even aircraft to make it to the launch pad. So really what you see here that's provided and remains fixed on the ground is that fence, the poles, the lightning protection system, and the tent. But everything else we bring with us to the pad, and that's one of the things that makes Astra unique, is that really all we need is a concrete pad and an internet connection, and we can set it up ourselves.
And we have another question from chat asking, is 2025 a good year to graduate in aerospace engineering? Potential Astra hires in chat.
I will say our future plans are very exciting and they don't stop at 2025. So I would say that any year is a great year to graduate in aerospace engineering. But I think also one of the exciting things about the team here at Astra is we have a ton of aerospace engineers, but we come from many, many different backgrounds. A lot of folks who come from software companies, from robotics, from the automotive industry. I myself have a background in biomedical engineering, so we have a very diverse team here in terms of our background.
We're coming up on T-minus 35 minutes and counting. Again, if you have any questions about today's launch, go ahead and tag us with @NASASpaceflight, where we'll continue to answer as many of those as we can as the countdown progresses. Of course, once we get a little later into the countdown, we're going to give some more updates about what exactly we'll expect during this flight and keep you updates on the countdown as it progresses. But right now, clocks are still ticking. The next question in chat, Sonia asks, what happens to each stage of the rocket after launch? Will anything remain in space, or will all return to burn up in the atmosphere?
Yeah, so our rocket is not reusable. So the first stage will fall back into the ocean, and then the upper stage will once it reaches orbit, will be deorbited and burn up in the atmosphere. So we do consider it very important to be responsible stewards of space. We do not want to leave any space debris up there in the future, and so our upper stage will burn up in the atmosphere. And similarly, many of the small satellites that we would take up in the future would be would have a limited lifetime and burn up in the atmosphere as well.
Another question in chat, and you know what? It would not be a NASA Spaceflight live stream without a question quite like this. A question about what are those towers around the launch pad? Those light poles around the site look like they must take a beating. What kind of protection does your pad equipment have against rocket exhaust and potentially other things? Because, again, we can't not ask about the poles around the rocket. It's a thing around here.
Yes, now I'm prepared for that lightning system question. So that is our lightning protection system, which helps keep all of our equipment safe in the event of lightning in the atmosphere. And certainly it is not a very forgiving environment being out on the launch pad, but we do protect a lot of the strong back, which is that tall arm which you see has a lot of plumbing, and protect it as much as possible from the exhaust of the engines. But otherwise, because our rocket's relatively small, we expect it to lift off. Everything else on the pad is in pretty safe condition, and most of the beating that the lightning protection system will take is from the elements out there in Kodiak.
You know, while we're looking around some of the other things surrounding the launch pad, we do notice one other thing. There are a lot of open gates around this rocket. Not a coincidence, I don't think.
You know, keeping the gates open is actually a standard part of our launch procedure, but it was a very good thing to have the gates open during the LV0006 flight because it very politely went right out the gate.
Good to see that's still in place. Keeping some questions coming from chat, we have a question asking, how long will the first stage fire during today's ascent?
Yeah, so closer to our T0 time, we'll go through the detailed mission profile, but first stage flight is about 3 minutes long.
And how does that compare to the upper stage? The upper stage fire is longer, right?
Yeah, the upper stage fires for closer to 6 minutes, so our overall time is to reach orbit is under 10 minutes.
Gotcha. And when we're talking about the flight profile, we had another question in chat asking, can you go over what would be considered a fully successful flight profile for today's mission?
Yes, our main objective today is reaching orbit. So that would mean the successful completion of passing through max Q in first stage flight, then main engine cutoff. Then we'll separate the fairings and the first stage from the upper stage. The upper stage will then light, and at second engine cutoff, or SECO, we will have reached orbit, and at that point we will send that signal to simulate the payload deployment. Again, we will not be deploying a payload on this flight.
And next question, we talked about the red team earlier. A shout out to them working out in the cold. Can you tell us what is actually the red team?
Yes, so our red team is the very, very small team of folks that goes all the way up to Alaska with the vehicle. It is a small team because we want to be pretty nimble, but we also want to maintain enough folks that we can have a buddy system and maintain safety. So we give a huge shout out to them. I can briefly go through who our red team is today. Our red lead, who is responsible for all the activities and safety of launch pad related operations, is Adam Frisch. Then red 2 is Hill Hudson. Red 3 is Robert Freeman. Red 4 is Eric Larson. Red 5 is Sam Hirschap. And they are all the folks who operate the hands-on hardware before our remote systems take over. So they're out here making sure that the rocket is set up appropriately, that all of our ground support equipment is in good shape. And then we have our IT, Eric Steinberg, who specializes in our communication systems and AV system. We've been working a lot with him to make sure that this live stream goes smoothly. And finally, safety is Ryan Hirschfeld, and he's responsible for the overall safety of our launch operation, including making sure that personnel are complying with our safety policies and procedures.
We also have a lot of other team members that we want to introduce. Really quick, before we continue, we should point out that we have just entered a hold at T-minus 30 minutes. We'll get you an update on that as soon as we can. But let's look at the other team members who are working on this hold right now.
Yes, so the camera that you are looking at right now is focused on our mission control here in Alameda in our HQ. And as you can see, again, it's a pretty small team, and I can briefly go through the folks who are in mission control. First, we have Chris Hoffman, who is our flight director. He is responsible for overseeing and directing launch vehicle operations following the countdown with the authority to call, hold, recycle, or abort as required. As a fun fact, on the side, Chris Hoffman runs Rocket Cat Rescue, so we love to support Rocket Cat Rescue here at Astra. Then to his left, with the googly eyes, Thomas Arend, who just stood up, is our flight activities officer, and he's responsible for logging the day's activities and making sure that we note any actions that need to be completed after the fact. Continuing clockwise, Chris May is Command and Data Handling, or CDH. He monitors and adjusts state machines as needed and follows the commands of the flight director. Then Joshua Green is our vehicle controller with a call sign Tango, and he's responsible for operating the terminal, which actually controls the vehicle systems under the direction of flight director. So you'll be hearing a lot from Tango as we proceed through the countdown. Dan Wilson is our GNC, Guidance, Navigation, and Controls guru, and he's responsible for making sure that wind and weather trajectory information is up to date, properly loaded, and meeting all of our flight criteria. And finally, Lucas Hunley, which is flight safety, call sign FTS, who's responsible for our flight safety system and making sure that all of our systems are operating nominally.
That's a look at the Astra team, and that team is currently working a hold at T-minus 30 minutes. In addition to the people we just saw, there are some other call signs that we may hear later in the countdown too that we didn't actually see there, right?
You're right. Outside of mission control, we have what we call the engineering backroom, who are the engineers who are responsible for their respective systems on the vehicle. And so they are not in a control room, but they're actually distributed throughout our office. They sit at their desk and monitor their systems. And you'll hear folks like ACE, who's our ground software system. Odin is our flight software. Delphin and Ether are our engines. We have Booster, which is the first stage system. Orbit, which is the second stage system. And Launcher, our ground support equipment. And you may also hear Panther, who is our backroom engineering coordinator.
While those teams continue to work this hold, we're going to take a break from the commentary so we can look and see if we can get you an update on the status of today's countdown. So let's listen into the pad mics as Rocket 3 sits ready to prepare to re-enter the countdown, hopefully here shortly. Okay, Lena, do you have an update for us on the hold at T-minus 30?
We do. The team is taking some extra time to verify some of the upper stage systems on the vehicle, but we're hoping that we are able to verify what we need to confirm and proceed with our countdown shortly.
Meanwhile, we'll go back into some questions while we wait for a resolution on that hold here. So the next question from chat comes from Josh, asking how much does this rocket cost and what's the target price when manufacturing becomes more streamlined?
So I can't talk specifically about price, but what we can talk about is some of our manufacturing technologies and what we're building to scale. So from day one, our mission has been daily space delivery, and we were always designed to scale. We know that high performance bespoke vehicles are very, very expensive, so we have designed a mass production vehicle, which has been our strategy, and we've been iterating on this design for years. And our approach is that every version of this rocket becomes less expensive to produce and to manufacture and to operate. And as we are able to scale this process and offer more launches, it could provide an opportunity, for many of our customers to allow us to offer them more services, both less expensive services and also more responsive services with the high frequency of launches that we hope to deliver.
Speaking of streamlining and simplicity, we have another question in chat asking why the simple names like rocket and launch vehicle?
Yes, we are on a path to scale for everyday launch, and so we want to always keep that in mind. And so we keep things simple. One of our values is simplify to scale, and using simple names like rocket and LV, and using serial numbers, even though they're low numbers right now, we will hopefully grow to many numbers in the future.
There are certainly a lot of zeros in front of the serial number right now, so there's definitely room to grow. We see that happening.
Absolutely.
Another question from chat. We are in a hold right now as teams work some upper stage data. So a relevant question now is how long is the window for today's launch?
I believe we do have a couple more hours remaining in today's window, and we do have another opportunity tomorrow should we not be able to successfully launch tonight. But again, we are keeping our fingers crossed that we're able to verify what we need to double check on the upper stage, and we will hopefully be picking up the count soon.
While teams continue to work this hold, we're going to show some highlights from the factory tour, which Astra was so kind to show me around here in Alameda not too long ago. And we've got some interesting footage from that we can look at. So let's take a look. So what are we looking at out here?
Yeah, so this is an old jet turbine engine test facility. This is Astra's current rocket engine test facility. So what you're looking at is two test cells that started out identical. They used to be used for, like I said, jet turbine engine testing, and each test cell has 3 towers. For jet engines, you actually burn the fuel using the oxygen in the air. So that first tower is actually the inlet tower. When you're moving so much mass flow because of the amount of gas that you're producing, you pull a pretty strong venturi through there. So the center tower is actually just to allow mixture air to come in and dilute the exhaust air. Then we have an acoustically damped tunnel there, and then an exit tower. So because our rocket supplies its own oxidizer in the form of liquid oxygen, we actually don't use that first tower. So we just close it off and we use the latter two.
Can we go take a look inside?
Yeah.
Let's do it.
Yeah, so these doors are color-coded. Green means you can enter, there's nothing dangerous going on. Mm-hmm. Yellow means go in with safety glasses if you have business being in there. Red means don't go in.
Gotcha.
So they're green, so we can go in.
Sounds good.
So we're stepping through about 2.5 foot thick concrete barriers into the test cells, which are a little bit colder than everything else. But basically what you're looking at is a kind of a rocket deconstructed. Mm-hmm. So you've got a liquid oxygen tank, you've got a fuel tank, you've got valves, you've got metering devices, you've got flow tubes. Anything the rocket might be able to do, you can simulate here, running different pressures, different flow rates, all of that. We've got things like load cells, so we can tell, usually I describe this to people as the fuel efficiency of the engine, which is more digestible than ISP.
Right.
But yeah, that matters a lot, as you know, for actually being able to get to space. So the combination of the flow meters and the load cells actually give us that data. I mentioned before, there are 3 towers per test cell. The intake tower is the one that's above us, so this air diverter is actually not being used. This is in its stowed position. We didn't have to do anything for this. And then I'll show you the other 2 towers as we walk through here. So if you can imagine, across those big black pipes there, a jet turbine engine was hung from those pipes and made fire down the tunnel.
Gotcha.
So this stand is designed around the full thrust of our first stage. You can see it's quite beefy. We use it only really for 1 engine at a time here presently, but the structure of the stand is designed around that sort of capacity.
And this would be a vacuum engine based on that bell, correct?
Yeah, so this is a vacuum ether engine, an upper stage engine. You'll also see right in front of Zach here, this is our ground-based igniter.
Oh, okay.
So that, by removing the igniters from the engines, we actually removed 33 valves from the rocket.
There you go.
Very clever ignition system, uses very simple methods and pieces of equipment. Not a lot of crazy custom stuff. I'll say that.
Interesting.
So this actually, it replicates exactly what's on our launcher, and there's an additional actuator to move this whole table out of the way so that we don't overheat during a full duration hot fire, because our launcher is not designed for full duration fire next to it.
Yes.
So this is a upper stage engine. If you stand over here and just face me, you'll notice that one of your ears is probably hearing a little less than the other, because this is an acoustically damped chamber. So you'll hear less coming from this side than you will from that side.
A little bit, yeah.
Yeah, so it's really damped. It's quite effective. So when we're doing hot fires here in the test cells, it's actually it's quieter than a plane flying overhead from the Oakland airport.
Ah, very, very cool. The Astro teams are still working a hold at T-minus 30 minutes. We'll continue to provide updates as soon as we have them. In the meantime, we are joined by Will Drury, Vice President of Supply Chain here at Astro. Will, thanks for taking some time to come chat with us.
Yeah, absolutely. Thanks for having me.
Let's start off with a question about what you're doing here at Astro. What is your job or your responsibilities as VP of Supply Chain?
Yeah, so my responsibilities as the VP of Supply Chain is that my team is responsible for sourcing all the parts and components that we use to build a rocket, getting those parts here to the factory where then we can receive them, store them, and distribute them to all the teams that need to use them to build the rocket. And once we've built it, our team is responsible for also just transporting it up to Alaska or wherever else we're going to be launching.
And I believe we actually have some pictures of your team doing
when we shipped our rocket and strong back up to Alaska. And so this first picture here, you can see our high cube, which is the base of our launcher system, and the rocket and strong back are in the shipping container in the background there. Believe it or not, the entire crew actually flew up alongside this payload on the C-17. Here's another really cool picture. We have our head of engineering and also Chris Hoffman, who leads the launch operations team. And we are all there in front of the plane. You can actually get a sense of the scale. This is one of the largest planes that the Air Force has in its fleet. The only thing larger than this would be a C-5. And this is also a very cool picture. You can see the plane as it takes off. There are a lot of really cool days here working at Astra, but I have to say that this was one of the coolest days.
It is very, very, very cool. And sending the rocket off on that plane to Alaska must be one of the last steps in your journey, right?
So that's what most people would think. But actually, our team is responsible for everything up until we launch the rocket. So if the team needs any spare parts, if people need to fly up last minute, we're responsible for making travel arrangements, chartering flights, and doing all the things necessary to get the stuff there.
That makes sense, of course. How has your background prior to Astra helped prepare you for this role here?
Yeah, so I've done lots of things. I started my career in federal consulting, so I worked out of Washington, D.C., and also spent some time overseas in Iraq, working with factories there. I moved out to Silicon Valley about 10 years ago and working in supply chain and automotive, and I spent some time in the startup world in robotics and in construction. So I've, over the years, really just gained an affinity for supply chain, and it's been really cool to just apply some of the lessons that I've learned from those other industries to the aerospace industry here at Astra. And I think even the approach that we take to building a rocket is very different, where in most companies it's like an engineering project, and here we treat the rocket much more like a product that has a bill of materials and has a production cadence and so on and so forth.
That's interesting. How closely do you work with the engineering teams? Because as supply chain person, you have to be balancing the potentially higher performance, maybe higher cost materials or components to source versus some lower cost options that might have a performance trade-off associated with it.
Yeah, that's a good question. We work very closely with the engineering teams. So our engineering teams are responsible for specifying all the parts that we use on the rocket. So you can think of this like they give us all a description of what they need and all the drawings that we need to have our supplier partners go out and make. And they're the ones that actually work with us to make sure that we're getting the right parts and the right level of quality. And you asked another question about like the level of quality that and how we balance high cost, high precision parts versus lower cost components. And one of the cool things, or actually two of the cool things about working here at Astra is that one, we're building a consumable rocket that does not need to be reused. So that makes things a little bit simpler for us. We need reliable parts that are going to work, but those parts don't need to be over-engineered to survive re-entry into the atmosphere. And the other thing is that we are launching payloads. So you know, when we're not launching people, we're able to experiment with different types of suppliers that wouldn't otherwise be available to just any other rocket builder.
That makes a lot of sense. How have you also worked to bring manufacturing and things in-house and vertically integrate the whole rocket production process for Astra?
Yeah, we're doing lots of things here. So another cool thing about being here is that doing supply chain at Astra is that we're building more production rates. So we can actually source things in volume, but that also means that we have some levers available to us in terms of automation. So our team's working really hard to actually build up an automated production line. Specifically, we're working on a really cool project for our first stage that would help us automate the production.
And now we're talking about materials and manufacturing, sourcing, and things like that. What about the human side of it? What are you looking for when you're sourcing human resources and the talent for your supply chain or greater Astra team?
Yeah, so our team has grown tremendously over the last year, and we expect to continue that trajectory into next year. We are constantly looking for great people. Aside from all the things that you would expect, like just having the right technical skills to do the job, we're really looking for people who are going to bring a certain level of creativity to this job. We're building rockets in a different way than most other companies, and we're just doing things differently. So I want people who are able to approach problem solving just from a first principles approach. This has been a very fun place to work. So I want to make sure that the people that we're bringing in are going to be a culture add and to help us to continue that amazing trend here.
Absolutely. One final question for you, Will. What is the most exciting part of Astra's mission to you personally?
So Astra's mission is to improve life on Earth from space, and that actually is very endearing to me because there are lots of companies that are focused on sending things out into the solar system, and I think that our mission of being focused inwardly on improving the lives of people here on Earth through improved communications, through imaging and things that will make it easier for us to track things like deforestation and all those types of problems, they really resonate with me. So that gives me meaning to the things that we do, and it's like a motivator whenever I'm thinking about a good reason to do what we do. That mission is really what motivates me.
That's awesome. Well, thank you so much for taking some time to come and speak with us on today's broadcast, and good luck with the launch.
Yeah, and if you don't mind, I have a few people I want to thank. So, this day wouldn't be possible at all without the support of our partners. We've had NASA, the U.S. Air Force, the U.S. Space Force. They've all been phenomenal partners for us, just helping us get all the resources that we need to make this possible. I also want to give a shout out to our supply chain team. They've worked tirelessly to make sure that we get everything we need to make this day possible. And also my family. My wife has put up with many early mornings and many late nights. And my 2 kids, Solomon and Makeda, they're amazing. I hope they're in bed right now. I can show them a recording in the morning, but they're also very excited about what we do here. So thanks to all of them.
Very cool. And Will, thank you so much for joining us today. Again, if you're just joining us, we're in a hold at T-minus 30 minutes right now. Teams are working on evaluating some aspects of the upper stage right now. We'll give you more updates as soon as we have them. In the meantime, let's listen into the countdown net and the mics out at the pad while we wait for some more information. And hopefully we can get this countdown back underway before too long. And if you're just joining us, we are still holding at T-minus 30 minutes as the teams work in upper stage evaluation. In the meantime, we're going to dive back into some questions. Again, if you have questions about today's launch, please tag us in chat at NASASpaceflight. We're answering as many of those as we can. And our next question comes from Matthew asking if Astra has an internship program in the works.
Yes, we do have an internship program at Astra, and you can learn more by going to our website astra.com, and checking out the careers page. We are hiring for a lot of roles across the company, both full-time and internships as well. So please come join us.
And a related question about the workforce here at Astra. Why launch so late? I mean, the employees must be very tired, says Luigi. And if this is a test flight, the rocket does need to go to a very specific orbit, correct?
Yeah, so the launch window timing is determined by the FAA, and actually because Kodiak is very close to Anchorage, Alaska, which is a very, very busy airport, we do try and minimize the impact, especially during this time of year, which can be very busy with holiday travel and lots of cargo. So really the simple answer is that that the FAA has determined that this is the window available for us for this launch, and the team here has been shifting their hours over to this night shift over the last couple weeks in order to minimize fatigue and be bright-eyed and bushy-tailed at these hours.
We got a question from Tiffany asking, I may have missed this when talking about the shipping container, but how tall is the rocket itself?
Sure. So the rocket is 43 feet long from tip to tail, and so that fits pretty snugly in a 45-foot shipping container.
And a related question from Max asks, why did you guys extend the first stage?
Yeah, so we extended the first stage between the Rocket 3.2 launch, which was in December of 2020, and our launch of LV0006 back in August. So at that point, we, after having very, very nearly reached orbit in December of last year, we took the opportunity to do some design changes to our system to help us scale to something that we wanted to produce at a quantity of flying at an approximately monthly rate. And so one of those changes was to stretch the first stage by about 5 feet, and that allowed us to get more propellant to keep the engines running for longer and get us a little bit more performance capacity out of that rocket.
Gotcha. Another question from Tim asking, what has been the biggest challenge of designing and manufacturing this rocket?
I can say there are many, many challenges in designing and manufacturing a rocket. As the saying goes, it's only rocket science, right? But I can say that one of the things that a challenge that I think we embrace at Astra is that we're trying to do things differently from the rest of the industry. We're trying to do everything in as a low cost and scalable way as possible, and sometimes that can be that can lead to challenges when we're trying to build and test and fly at a rate that no one has ever seen in the industry.
Next question for some of the views from Mission Control that we saw. A question from Patrick asking, why does GNC have a joystick?
So I don't know if we can switch to that Mission Control view, but we do have some funny things in Mission Control. You can see our GNC, Dan Wilson, who's sort of second from the left there, has a joystick on his desk. And I will say that's just for fun. The vehicle is entirely flown by an algorithm that is pre-programmed in flight. But otherwise, in Mission Control, we have some googly eyes on consoles. We have a really fun wolf blanket, not visible in the cameras, but we have some prayer candles for good luck as well. So these are just, most of these don't really have specific stories, but are more of a why not? We'll take all of the luck and that we can get, and we try and keep a sense of humor here at Astra.
I love it. Some more questions that have come through here. A question from Thomas, cool name Thomas, says, how long can the rocket hold while partially fueled? What kind of fueling state are we in right now, actually?
So I believe that we are fully fueled, and we can hold for for quite some time. This is a pretty stable state that the rocket's in, so we can hold for, I believe we have just under 90 minutes left in our window, so we can hold through to the end of that, but we can hold for several hours in this state as long as the rest of the systems are operating nominally, which at this point, aside from the question about the upper stage, everything else appears to be nominal.
Gotcha. Related to the fueling condition of the rocket, we're seeing a lot of vapors around the rocket and actually coming from the transporter erector next to it as well. A question in chat asking what we're seeing there.
Yeah, so a lot of what you're seeing is that really cold oxygen, that liquid oxygen that is much colder than the ambient temperature, and so it makes that sort of steam or smoke. And as well, we have vent lines to make sure that we're keeping the system at the appropriate pressure. And so that's that white pipe you see sticking off the strong back near the Astra logo, the American flag right there. That's just making sure that we're keeping everything at the appropriate pressures.
Another question from chat asking, does anyone know the path of the rocket? Would it be possible to view it from southeast Alaska and northwest British Columbia?
Well, oh, there we go. We have a great shot of the vehicle's trajectory there. So if you are near that area, you'll be able to see it. I can say from my own past experience, I grew up in Florida, and some of the night launches of the space shuttle were very, very clearly visible in the night sky. And so hopefully folks in that area can get a great view of LV0007 on its flight to orbit tonight.
You hear that, chat? We got the shuttle reference in for the NSF stream. You have to every single time. Today's mission is going to an 86-degree inclined orbit, I believe.
Yes,
is that correct?
That's correct. 500 kilometers and 86 degrees is the orbit we're shooting for tonight.
Gotcha. And related to the trajectory, we have a question in from chat asking, how does this affect the downstream boating or fishing in the area?
Yeah, so like I mentioned earlier, with our launch window, we try and minimize the impact that we have on travel in the surrounding community, and we work closely with the government in order to issue notices to airmen and notices to mariners, or NOTAMs and NOTMARs, to make sure that the area is cleared. And we also work with the Coast Guard to make sure that there are no boats in the keep-out area. We know that this can be a busy fishing season, and so we do our best to minimize those impacts as well.
Next question comes from Jordan in chat asking, why does the Astra Rocket 3 have 5 engines?
Yeah, so the first stage engines are built in-house and totally designed and tested in-house. They're known as the Delphin engines. And we have 5 of them because each of them produces about 6,500 pounds of thrust, and the total thrust that we need is worth 5 of them.
Another question asking for some specs on the thrusters used on the rocket. So you can give us some more detail about the engines and also maybe the upper stage engine too?
Absolutely. So like I mentioned, our engines, the Delphin engines on the first stage, as well as the Ether upper stage engine, are all designed, tested, and built in-house here at our headquarters in Alameda. And we have 5 of those Delphin engines on the first stage, each producing 6,500 pounds of thrust, as I mentioned earlier. Both stages are fueled by the same propellants, which is liquid oxygen and RPX, which is similar to kerosene. And then our Delphin engine is an electric pump-fed engine, so we use pumps that are powered by batteries to bring the propellants into the engine and ignite them. And then on the upper stage, that's the Ether engine. We have 1 of those, and it produces 740 pounds of thrust. And it is, as I mentioned, also propelled by LOX and kerosene, and it is a pressure-fed engine, so it is much simpler. It doesn't have those electric pumps. We rely on the pressure in the tanks to feed the propellant into the system.
This is Astra's 4th orbital launch attempt, and again, we were broadcasting live for LV0006, the precursor to this flight, and we have another question in chat. Can we go over again what changes have been made since the last launch attempt?
Sure. So for those of you who are just joining us, the issue that we saw with our LV0006 launch attempt in August was due to some fuel and oxidizer leaking at T0, a very small quantity leaking, and igniting under the very hot exhaust from those first stage engines, which caused some of the electronic components on those engines to shut down one of them. And so really the main change that we have made to the system is separating that fuel and oxidizer loading system and making sure that there is a much smaller likelihood that those can combine at liftoff. And in addition, looking at our verification methods, our test program, and improving those as well so we can make sure to catch these issues proactively in the future.
I believe actually part of that actually entailed relocating where those connections were on the bottom of the rocket, which the fact that you made that change after the rocket pretty much existed already before the previous launch is impressive, but that's kind of how Astro is built to quickly iterate in this phase of development, right?
Certainly, yeah. It was a very, very impressive effort by the team, a lot of work by members of the first stage team, of our test team, and we're very grateful for all of their efforts in getting us back to the pad as quickly as we could. Really, it's how we like to learn and iterate rapidly, and I think we have proven that with this LV0007 flight coming under 3 months from our last launch attempt.
Another question from chat asking, what material is this rocket made from?
Yes, one of the things that makes Astra unique is that we try and use much simpler materials, the things that are less expensive. We use a lot of aluminum is, I think, the primary material that our vehicle is comprised of, and we used as simple as possible. Our manufacturing methods are really as simple as possible, so that is, I think, one of the things that sets us apart, and is one of the ways that we think differently from the rest of the rocket manufacturers in the industry.
And we can see that you can look at the bottom of the rocket that you're seeing on your screen right now. You can see the bare aluminum near the bottom. That's going to be the kerosene tank, right? Because that's not as cold as the liquid oxygen tank above it.
Yeah, that's right, Thomas. So the liquid oxygen is that top part. It's very, very cold relative to the ambient temperature, and that's why you get that condensation on the outside, similar to when you're drinking a cold beverage on a warm day. But this is just much, much colder.
Right, and that's just the air around the rocket condensing. It's not actual material from inside the rocket getting out.
That's right.
Does that ice or frost that forms on the outside of the rocket affect the rocket's performance in any way? I mean, does it add a significant amount of weight or create more drag?
That actually will mostly fall off, and so it doesn't really impact our performance.
Gotcha. Another question from chat asking, can the rocket engines be recovered from this rocket?
Right, that's a great question. So at this time, our rocket is entirely single use, so we don't recover any part of the vehicle. And the first stage, including those engines, will land back in the ocean, and we are pursuing long-term options for sustainability of that approach. But the upper stage will deorbit and burn up in the atmosphere, but the first stage will land in the ocean. And landing from that altitude can be a pretty high energy event. So we, even if we were to recover parts of the vehicle, it may just be in small parts in the current way we operate.
Gotcha. And a question from Mike in chat asking, where can I buy some Astra merchandise? Any Astra merch coming soon?
Unfortunately, the only way to get some cool Astra swag is to come work for us, or to have a very close friend who does. So if you're interested in Astra merch, check out our careers page at astra.com.
Nicely done. Very nice. Another question from chat. This one's from Steven saying, since this is a dummy payload, will the payload fairing be deployed during today's flight?
Yeah, so fairing separation is part of our standard mission profile, and because the fairings are pretty heavy and they add drag once we are in space, we will deploy the fairings. I believe that happens. It happens right around the same time as stage separation. So a little closer to T0, we'll be going through the mission profile.
And that's actually a result of, because Astra's rocket is a little unique in this aspect, that it's not just the payload that's in the fairing. The fairing also encapsulates part of the upper stage, so you have to separate it for the two stages to separate, right?
Right, that's correct. So the upper stage actually extends part of the way into that fairing volume in addition to the payload. And again, tonight's flight has a test payload which will not be deployed, but we will monitor with cameras and send a signal to simulate deployment of the payload.
Again, if you have questions about today's launch, go ahead and tag us with @NASASpaceflight for an update on the countdown. We're still holding at T-minus 30 minutes. Teams are evaluating some upper stage systems on the rocket. We'll have more information. We'll share more information as soon as we have it. In the meantime, let's go ahead and listen back into the pad mics and the countdown net, and we'll come back with another update as soon as we have it. And if you are still with us here, we're at T-minus 30 minutes, and if you're just joining us, we've been holding for a little bit as teams evaluated an upper stage system. We're getting word now that teams are getting close to resuming the countdown, so we're going to keep listening into the countdown net for them to make that call out, and we'll have a new T0 shortly for today's launch attempt. Again, if you're just joining us, we are getting close to resuming the countdown and releasing this hold, so stay tuned, and we're going to listen in.
This is Astra flight on countdown. Clock has resumed at T-minus 30 minutes. We are picking back up the procedure at step 106. At this time, FTS, please verify mission data load values are ready to be loaded onto the AFTU. Run CAS software as required.
Mission data loads are loaded. CAS software is running on both AFTUs.
Copy, thank you. Safety, please confirm you have all guests and Astra personnel accounted for at launch site Kodiak.
Safety can confirm all guests in safety town.
And all personnel are in a safe location.
Safety can confirm.
GNC, please confirm for me that we are still good on COLAs and blackouts for our current T0 time.
Confirm, still good on blackouts and calls.
Thank you. RCO flight on countdown. At this time, Astra would like to request power on transmitter and enable tone A.
This is RCO, that's in work. Flight, this is RCO, carrier up, tones up.
Copy, thank you. Safety, please verify signal strength and good power up.
Safety can confirm good signal strength and power up.
Tango and AV1 rocket support cart, please enable the FTS.
AV1 rocket support cart, FTS enabled.
Safety, please verify FTS is enabled and nominal at this time.
Safety can confirm.
RCO flight on countdown. Astra FTS is enabled on the vehicle currently.
This is RCO, copy.
And as you can see, we have resumed the countdown. We're now at T-minus 28 minutes and counting, and we have a new T0 of 11:10 p.m. Pacific time. Teams have successfully evaluated the upper stage issue and have decided to proceed with the countdown. Exciting news for today's launch attempt. In the meantime, as we get closer to the business end of the countdown, let's dive back into some questions here. And the first one from chat is from Connor, asking what kind of or how much simulation work takes place before a flight?
That's a great question. We do a lot of simulation work, both in preparing and vetting our software systems for testing. But actually, one of the things that is happening right now, a little bit more behind the scenes, is we are sending a weather balloon up to get the latest weather data and winds. We've been tracking some upper level winds and potential wind shear issues. So within the next few minutes, we should have some more weather data that we will run simulations on while the countdown is happening and incorporate that information into our launch decision tonight.
Gotcha. Another question, this one from Mustang says, do you guys by any chance have a flight computer that takes over the countdown at some point?
Yeah, one of the most exciting things to hear during the countdown around at 60 seconds is a call out, vehicles on internal control. So we have one of our positions in mission controls, Tango, that's the human vehicle controller who's commanding the vehicle. And at that point, the vehicle takes on its own control, and our flight software and guidance algorithms run to keep it on course towards orbit.
A couple questions in chat about today's launch site. We've been talking about Kodiak Island, Alaska as the home for this test campaign. And for those of you who may just be joining in, why does Astra launch from Alaska?
Yeah, we have launched from Alaska for many of our launch attempts so far, and some of the reasons that we enjoy working with our partners in the Pacific Spaceport Complex, Alaska, and the Alaska Aerospace Corporation is that not too many other folks are launching out of Alaska right now, and so it helps us get availability. It also helps us reach the some of the orbits that our customers will want to go to. Kodiak is great for reaching high inclination and polar orbits, and we have really enjoyed partnering with the range there. It's also a great, very scenic launch site, although at night it's a little hard to see, but there's some lovely mountains, and it's right over the ocean, which of course is paramount for keeping the rocket away from populated areas and keeping all of our operations safe.
I'm personally hoping that in just over 25 minutes here we get some rocket exhaust to light up and maybe we'll get some more of that Kodiak landscape visible. Another question here relating to Kodiak. Do you guys have any problems with bears on Kodiak Island?
There's quite a lot of wildlife in Kodiak. Thankfully, we haven't in the past had any problems with bears, but actually, as we've been preparing this vehicle for a launch, we've had a little fox friend who has been spending some time around the launch pad over the last couple weeks. Luckily, usually animals will sense the vibrations of the vehicle and keep well away, and so our fox friend is nowhere nearby, and we work very closely with the range to keep everything safe during our launch operations.
Gotcha. Another question, will Astra launch from somewhere other than Alaska going forward?
Yes, our future plans definitely include a number of launch sites around the globe for many spaceports, but tonight our focus and our eyes are on Alaska.
We're at T-minus 24 minutes and counting. Again, we're targeting a new T0 of 11:10 p.m. Pacific time, and we have some questions about the launch window today. Does launching at night as opposed to during the day help or affect the rocket's path to space, asks Ethan?
No, it is all the same as far as the trajectory of the vehicle is concerned. Some of the differences are that it can be more visible from further away on a clear night because it's more the plume is more visually distinct, and some of the other differences in launching as night is right now being November in Kodiak. It's been quite cold, so we have had to change our procedures to operate differently in cold weather from our usually warmer launch attempts during the day.
Interesting. And another question regarding launch windows. If today has to end in a scrub, and again, we are back counting at T-minus 23 minutes, and so not talking about that just yet, but are there other alternate launch windows for this launch campaign?
Yes, we do have another opportunity tomorrow as well to launch if we are not successful in our launch tonight, but so far everything is looking good and proceeding according to plan. Just waiting on some of that weather data for the final go, no-go.
Sounds good. And another question here from John asking, while the rocket is not reusable, how reusable is the launch arm, that ground equipment we see next to it?
Yes, so the ground support equipment you see, that black arm is the launcher, and then we have our launch mount underneath is also a little harder to see, but those are reusable. Of course, they can sometimes take quite the beating from the intense heat and energy of a rocket launch. However, we've built this system to be as robust as we can, and even though it undergoes some repairs between flights, we have used this launcher on multiple flights, and will continue to use it for future launches.
While we're talking about some different components of the rockets and things like that, we actually have a graphic to show the different components of a Rocket 3, an Astra Rocket 3. Can you tell us what we're looking at in all the different sections we see here?
Yes, I love this graphic. This is fun. So we'll start from the left, which is the bottom end of the rocket, and we'll work our way up to the right. So the first section you see on the left is the engine bay, and you can kind of see peeking out 3 of our 5 Delphin first stage engines. So those each produce 6,500 pounds of thrust. And they are electric pump-fed engines, so the engine bay contains those pumps, the batteries that power them, and the connections to the first stage system. So the largest section, that's our first stage. Our first stage, which is consists of a LOX tank, the liquid oxygen tank at the top, and then the fuel tank at the bottom, which is RPX, essentially a form of kerosene. Then continuing to move to the right, the kind of cone-shaped segment, that is what we call the inner stage, and that essentially is the housing for a lot of our avionics. The upper stage engine and that long nozzle extension piece fit inside the inner stage. And then moving up to the final section, you see the long black nozzle of our upper stage ether engine, which is a pressure-fed engine also powered by LOX and RPX, which produces 740 pounds of thrust. Then the 2 spheres, those are our upper stage tanks. And then on top you can see our payload adapter plate, which will have a payload on top. Again, for tonight's mission, we have a test payload that will not be deployed. And finally, the 2 halves kind of floating above and below the upper stage, those are the fairings. And we remove those to install the payload and then reinstall those 2 fairing halves together.
There we go. As we go through the countdown, we're under 20 minutes and counting now. We're going to listen into the countdown net as the teams are getting through some milestones as we get closer to launch.
For launch.
Stand by on that flight.
Understood. As GNC evaluates, we're going to finish out our igniter checks at step 134. Tango, please, on the buttons interface, toggle spark for 30 seconds.
Copy, spark coming on in 3, 2, 1. Spark off.
Dolphin, please confirm results.
Spark current looked nominal. However, can I request an additional spark check after purges?
Copy that. Tango, can you please run an igniter purge for 2 seconds on all 5 igniters?
And work. Starting with Alpha, working to Echo.
And as we're now approaching T-minus 17 minutes to launch, one of the next things that we'll see is a test of our water deluge system in the next couple of moments.
Spark on. Spark off.
And we just crossed that T-minus 15-minute mark. We are expecting to potentially be in a hold for a few minutes as we wait for wind data, and that's probably the reason why the deluge, the water system test, has been held off for a little while.
We're going to keep listening in to the countdown net, and we will have more updates for you as soon as we have them.
All right, and we are holding at T-minus 13 minutes and 47 seconds as we look at that wind data. We're looking at potentially a 10-minute hold.
And as you've seen, we are still in a hold right now at T-minus 13 minutes 47 seconds. Teams are waiting for some wind data. In the meantime, since we think this might be about a 10-minute hold or so, we'll take some questions in the meantime. We got one here asking about the upper stage engine. Carolina, is it the same as the sea level engine, or with just a more vacuum optimized nozzle, or is it a completely different engine?
They're pretty different. The first stage engine, the Delphin engine, and the upper stage Ether engine are pretty different from one another. So I know it's pretty common for upper stage engines to be slightly modified versions of the boost stage engines, but in our case, they're pretty different.
Next question asks, where is mission control located for this launch? Is it in Kodiak?
Our mission control is actually here in Alameda, California, which is our headquarters, and it's one of the things that keeps us as nimble as possible. There you see the mission control camera that's right behind where we're coming to you from. So we send a very small team up to Alaska with the vehicle, and we keep most of our team here back at headquarters.
And this is, of course, the headquarters building where the rocket is also built, correct?
That's right. We, here at our campus in Alameda, we build and we do a lot of our engine testing as well. And it helps us stay fast to do everything as much as we can under one roof.
How long does it take for the rocket to get from the factory here in Alameda to Kodiak, for example, for launch?
Yeah, so that can depend on the mode of transportation, and it also depends on the shipping schedule and what boat we can make. But it generally takes about a week for all of our equipment to make it from Alameda over road and boat to Alaska. But a lot of our equipment can actually be flown for maximum speed, and in which case it can be there in a matter of hours.
Another question from chat asking if this launch is successful, what is next for Astra?
Well, hopefully more launches, but we'll keep our eyes focused on tonight's launch of LV0007, and you can follow us on Twitter at Astra or visit our website for more information from our blog posts, press releases, and SEC filing for more information on Astra's future plans.
Next question asking if the ground team, we just looked at mission control a little bit a second ago, does the ground team have any control of the vehicle after launch other than FTS activation?
Right. Our vehicle, once it launches, is being flown by itself by the algorithms developed by our flight software and our guidance teams. So aside from our flight safety systems, which we will use in the event that the rocket is off course, everything after launch is being done by the vehicle itself.
Our next question asking, how does Astra tackle water noise suppression?
Yeah, so one of the things that you will usually see, I think we saw a smaller version of it while we were just going through some of these questions. It's a bit hard to see, but we do have a water system around the base of our rocket that is primarily for fire suppression, but it also serves a purpose of noise suppression as well. So we do have a water system there to make sure that we don't light anything that we're not supposed to be lighting after launch.
Gotcha. And yeah, we might have caught a glimpse of that as we're getting in the area of the countdown where they do a deluge test. So we're still in a hold right now. 13 minutes 47 seconds is where the countdown clock is, and we're waiting for another update. We're waiting on wind data primarily, as making sure the winds are acceptable for launch. So we're going through some questions in the meantime. And the next question is from Alex asking, wouldn't it be easier to get to orbit if you launched closer to the equator?
Yeah, launch sites generally help determine which kind of orbits the payload can reach as well. And in the case of launching from Kodiak, many higher inclination and polar orbits are actually easier to reach than launching from the equator. And so the choice of launch site has to do with the mission itself as well.
Next question from Matthew asking, what is the launch trajectory of this rocket?
And I think we've got a map to show what the launch trajectory is. So we'll fly out south over the Pacific Ocean, and you can see that we'll see that trajectory once the rocket clears the pad.
And the next question, because all flights have happened from Alaska at this point, we just saw it on the map there, do they take the Strongback and the other GSE equipment, so when we talk about GSE, ground support equipment, all the things around the rocket you see on your screen right now, do those get taken apart and shipped back to the headquarters between every launch?
Yeah, actually, we don't leave much behind up in Kodiak, and so we do ship pretty much everything back here to Alameda, and we perform maintenance and repairs. Again, that launcher system, the Strongback and launch stool that you see, as well as some of these other shipping containers that you may see at the bottom of the screen, that will all come back to Alameda for repairs and maintenance.
The next question from Chad, here's a good one. Who is the guy with the smiley face on the back of his computer monitor?
Well, you can see on the right-hand side of your screen those googly eyes on that monitor. That is our flight activities officer, Thomas Arend, and some of the questions we've gotten are, what's the story behind the googly eyes, and it's more of a why not kind of situation. There was a big box of googly eyes around the office one day, and quite a few things got some eyeballs there.
Alright, if you're just joining us, we're in a hold right now. Teams here in Mission Control at Alameda are looking at wind data and making sure that that is acceptable for launch. We're standing by for a new target T0 time. In the meantime, if you have questions, please tag us at NASASpaceflight in chat. We're going to keep going with those once we have some more questions coming in. In the meantime, let's go ahead and listen back into the countdown net and the microphones out at the pad while we wait for some more information on this hold.
And we are still in a hold at T-minus 13 minutes and 47 seconds, but we've just gotten word that the weather data that we were waiting on is looking favorable, and we expect to be resuming the countdown any moment now. So thanks for sticking with us through this hold, but we are hoping that we will be out of it soon and on our way to orbit shortly.
This is flight on countdown, entering terminal count at procedure step 141 at this time. Tango in AV1 manage power systems. Please ensure guidance power system authority is toggled off.
Confirmed guidance system power authority is off.
In VB1 turn on off PDBs, please run a GNC self-test. GNC call out when complete.
GNC self-test started.
FTS, please confirm Astra FTS is still enabled on the vehicle.
FTS is still enabled on the vehicle.
Tango in fuel 4 operate toggle full.
Fuel 4 operate full.
And as you see, we have entered the terminal count. We're at T-minus 14 minutes and 33 seconds and counting. The new T0 is 11:25 p.m. Pacific time. Now that we are into the terminal count, we're going to look at an overview of the flight profile and what we'll expect to see once we have liftoff here from Kodiak. Carolina?
Sure. So we'll start from the bottom and work our way up with that mission timeline. A few seconds before T0, the engines will ignite. If all is good, we will send a signal to the hold-down release mechanisms on that launcher system to release the rocket, and we will have liftoff at T0. Just a few seconds later, we will pitch over the rocket, and then our next objective is max Q at 1 minute and 10 seconds. Following max Q, which is the point of maximum aerodynamic pressure on the vehicle, we'll be looking for main engine cutoff, or MECO, at 2 minutes and 50 seconds. And then a few things happen in pretty quick succession, which is fairing separation, stage separation, and then the upper stage ether engine will light at 3 minutes and 5 seconds. If we meet all of those things, then we'll be in space, and it will be very exciting. And then the ether engine will burn for a little over 5 minutes before second engine cutoff, or SECO. And our final step in the mission will be to send a signal to simulate payload deployment. Again, we have a test payload on this flight which will not be deployed, but we will monitor to see if the signal to simulate the deployment is successful at 8 minutes and 40 seconds. Again, our objective today is to reach orbit and successfully complete all of these steps on our mission timeline.
Yeah, and so what is coming up next? We're at T-minus 12.5 minutes and counting. We are coming up on the next big milestone, which is the go, no-go poll for launch. So we're going to listen into the countdown net as the teams get up to that and poll go, no-go for launch.
Toggle off and deactivate. Fuel 4 operate.
Fuel 4 operate deactivated.
Fuel 3 supply.
Deactivated.
Fuel 1 FE 300 upper fill.
Deactivated.
Fuel 1 FE 200 first fill.
Deactivated.
AV1 radios.
AV1 radios deactivated.
AV1 rocket support cart.
AV1 rocket support cart deactivated.
Flight on countdown. Astra is scrubbing at this time.
And as you've just heard, unfortunately, with just a few minutes left in our countdown for this evening, we unfortunately need to scrub tonight's launch attempt. We'll provide more information as we can share the cause of that scrub. But the good news is that we have another opportunity to launch tomorrow. So please join us again at the same time tomorrow. Nominal T0 time would be 9 p.m. Pacific time, with the live stream beginning at T-minus 60 minutes.
Yeah, from NASASpaceflight, a big thank you to Astra for trusting us to help them with this broadcast, and again, helping them with some of the expenses related to making this happen. We will, again, be live hopefully for another launch attempt tomorrow, but we are scrubbing tonight's attempt Just a couple minutes left in the count, but unfortunately today's launch attempt has scrubbed, and our next attempt is tomorrow. For everyone who tuned in, thank you so much for watching. Thank you so much for all the questions in chat and all the support that was sent in. We really do appreciate it. We hope you'll come out and join us tomorrow for another launch attempt. Thomas Burkhardt for NASASpaceflight and Carolina Grossman for Astra. Carolina, thanks for joining me tonight.
Thanks, Thomas. Have a good night.
All right, we'll hopefully be back tomorrow. Everyone, thanks for tuning in, and we'll see you next time.
Propulsion continues to be normal.
Our EPA chamber pressure looks good. Throttling up. Roger roll, Atlantic.
Water towers can fly!
Tango Delta nominal.
Flight downside speed off. Bring in, let's speed off.
Yikes. You bet. Concur. We don't need any more of these.